New Syllabus Mathematics Book 1, updated 7th edition, chapter number 1, Primes, Highest Common Factors and Lowest Common Multiples, exercise 1B, question number 14. Mars is an art elective program student who is working on an assignment. He plans to cover a rectangular sheet of paper of dimensions 126 cm by 108 cm with identical square patterns. Now, first part from this question is, what is the least number of square patterns that could be formed on the sheet of paper? And then second part from this question is, how do you determine what other shape can the patterns be if they are to fit the sheet of paper perfectly? Explain your answer. Now here is the required sheet with a length of 126 cm and a width of 108 cm. To find the least number of identical square patterns that could cover the sheet perfectly, we first need to determine the size of the largest possible square that can fit into both the 126 cm and 108 cm sides of the rectangular sheet. Since the rectangular sheet will be covered by squares of the same size, therefore, the statement refers to the highest common factor HCF of the numbers 126 and 108, or the largest square that can fit into both sides is determined by finding the highest common factor HCF of the two dimensions, that is 126 cm and 108 cm. So prime factorizing 126 results in 2 times 3 times 3 times 7, and factorizing 108 gives us 2 times 2 times 3 times 3 times 3. The highest common factor HCF is the product of the common factors, which in this case is 18. Now here 18 is the length of the side of the largest square. To find the total number of largest squares that can fit into the rectangular sheet, I will divide the total area of the rectangular sheet by the total area of the large square. The total area of the rectangular sheet is the product of its length and width, while the total area of the square is the product of its two sides, that is, length multiplied by length. Here the total area of the rectangular sheet is 126 cm by 108 cm, which is equal to 13,608 square centimeter, and the total area of the square sheet is 18 cm by 18 cm, equal to 324 square centimeter. Now dividing 13,608 by 324 gives us 42. Therefore, the least number of square sheets, or the maximum number of square sheets required to cover the rectangular sheet, is 42. Here is the rectangular sheet, and we can cover the rectangular sheet with 42 squares. The total number of these squares is 42. Now, for the second part of the question, we will identify the other shapes that can completely cover the rectangular sheet. There are other shapes that can completely cover the rectangular sheet. For example, if we divide each square into 2 right-angled triangles, then 82 right-angled triangles are required to cover the rectangular sheet completely. The other shapes that can fit perfectly would be rectangular shapes, where both sides are divisors of 126 and 108. To find these, we need to list the divisors of both numbers. Now, divisors of 126 are 1, 2, 3, 6, 7, 9, 14, 18, 21, 42, 63, and 126 itself. Divisors of 108 are 1, 2, 3, 4, 6, 9, 12, 18, 27, 36, 54, and 108. The common divisors of 126 and 108 are 1, 2, 3, 6, 9, and 18. So any of these common divisors could be used as the side lengths of rectangular patterns. For example, we could also use rectangular patterns like 18 cm by 6 cm or 9 cm by 3 cm, as long as both dimensions divide both 126 cm and 108 cm evenly. Therefore, other than squares, rectangles, right-angled triangles, and trapezoids can fit the sheet of paper perfectly.